So today we're going to do a podcast about system analysis and design, where I will align everything about system analysis and design at a level standard. This is going to be a long video, so if you don't want to watch the podcast, I will link other videos of my usual content in the description. Introduction. System analysis and design covers the activities involved in developing new systems. It is the process of analyzing particular systems, scientific, business, or control, to see if replacement or upgrading would yield a more useful, productive, and profitable way of performing the business operations. System analysis and design involve system analysts. System analysts are deeply involved in analyzing the data processing requirements of an organization in whole or in part, deciding what, in consequence, the computing system should do, specify the task of computing system in detail so that the technical specialists, aka programmers, can do their work, ensure that the developer computing system ensure that the developed computing system works efficiently. The system is a collection of interrelated components that work together to achieve some objective. Different components making up a system include hardware, software, collection of data, work of number of people. Different components making up the software components of a system include input, processes, stored data output, human communication interface, HCI. A commercial or industrial enterprise can be defined in terms of system elements. Physical, example buildings, raw materials, finished product. Procedural, other processing routines, credit checking, procedures. Conceptual, example statement of policy, material for product, or social, example workers or departments. System and environment. The system operates in an environment and relates to the environment, which itself includes various elements. Elements relating to the environment include physical, example transport routes, procedural. Man, this fucking word doesn't even get out my tongue. Example codes of practice, legal requirements. Conceptual, example monetary system, political ideologies. Social, example trade unions, suppliers, customers. An enterprise can be divided into a number of subsystems defining the functional areas. These include those dealing with the environment, marketing and purchasing subsystems, those dealing with transformation functions, the production subsystem, those acting in a supportive role, accounting, personnel, and management service subsystems. Business subsystems. These subsystems are all interconnected. The diagram shown is a simple model of a business subsystem. The diagram illustrates the interface within the business and hence the type of difficulty that can arise in defining boundaries. Hence for the difficulties of the system analyst to analyze, design, help, implement, or review. Personnel, management, budget. Objective of computerization. This is done to reduce costs, take advantages of facilities offered by computers, to increase volume of business, better management of information, enable long-term forecasts, and enable better planning. Even scalability. Types of data processing systems. Systems where processing is done periodically, batch system or file processing system. Large volume of data coming in at regular intervals, but where processing does not have to be done immediately. Example, payroll system, gas billing system, database system, online systems. An online system is one in which information is available to all users at their own terminals, although they may not be able to update the information. Independent of any individual application, store of information. It is independent of any individual application. It is a store of information to support other data processing systems. Remark, in many instances, the above types then use a data communication system to transmit data from one place to another. Types of data processing systems. It continues with the types of data processing systems I said before. Real-time systems. The computer has to keep pace with some external operations, processing that receive data more or less instantaneously, and producing results immediately. Example, process control. In oil refining process, which is computer controlled. Information storage and retrieval. Example, medical record systems. Through shared data files, by nature of application, a single record is not accessed by more than one user at the same time. Transaction processing. Example, online reservation system. By nature of application, the same record may be accessed by different users at the same time, hence need of data locking. The system life cycle, SLC, short. The development and maintenance of new software system involves a series of stages. The system development life cycle, SDLC, or simply the system life cycle. The term life cycle indicates that the process of development and maintenance never ends. The development of a system may take from a few weeks to a few years. The SLC is a model which tries to maximize the chance of successful project development. 7 out of 10 IT projects fail in some respect. This is a quote of some OASIG study, some sort of a company, I think. The waterfall model. This SLC model, system life cycle model, consists of a number of stages. Stages may be characterized and divided in different ways: project definition, feasibility study, system study and analysis, system design, implementation, meaning coding, testing and integration, control and review. The waterfall model. The waterfall model is a very rigid model. It is a sequence of stages where the output of each stage becomes the input of the next. In a rapidly changing environment and where up-to-date software systems are required, this model does not work. The model assumes that all system requirements can be identified in advance. In practice, most often, this is not the case. This model assumes that users are only to be involved in order to specify system requirements. The spiral model. This method allows the development team to progressively complete a project by repeatedly going through the stages of analysis, design, and implementation. First we go to analysis and design implementation, back to analysis, design implementation, back to analysis, design implementation, and go on. twice the spiral model. The incremental iterative model goes from analysis to design. The design is subdivided to component A, which there is analysis for component A, which is subdivided to design and subdivided into implementation. Then you have the same for component B, same for component C, and then there's the implementation of the system. The incremental iterative model. The project is divided into sub-projects, and then the waterfall method is performed on each sub-project. Instead of completing functionality of the entire application with each pass, the incremental iterative method completes components. Each component does not necessarily become a deliverable that is usable by a client, though at milestones the components are joined together to create a usable product. This approach to project development promotes the development of reusable code and promotes the separation of functionalities required into different components, example GUI controls, data access, etc. And it helps clarify exact functionalities required. Throwaway prototyping. The objective is to understand the customer's requirements and hence develop a better requirements definition for the system. A mock-up. A mock-up of the proposed system is produced for demonstration purposes. Prototype has appearance of the final system but lacks any real processing or storage capabilities. Trial prototyping. A simplified working model of a proposed system serves for demonstration purposes. It also provides an opportunity to try out ideas and investigate specific points of interest. Rapid prototyping, also known as evolution prototyping. The objective is to work with the customer to explore their requirements and deliver the final result, the final system. The development starts with the part of the system which are understood. The system evolves by adding new features as they are proposed by the customer. Rapid prototyping is particularly suitable for small-scale systems which are required urgently and which have a limited life. When it is difficult to establish a detailed system specification, example AI systems which attempt to emulate human capabilities. Rapid prototyping. Evolution development. There's the first it outline project description. Then the concurrent activities, which are divided into specifications, development, validation. There's the initial version, immediate version, and final version. Comparison of prototyping strategies. Remarks re-prototyping. Throwaway methods aid work done in analysis and design by being incorporated into the development lifecycle. Evolutionary methods provide short-term gains, rapid results, but on long term can become costly, difficult to maintain, and tend to be less reliable. Project definition. This is the initial stage of a project development. This initial stage of project development is an attempt to formulate project project requirements in broad terms by identifying exact reason for project selection. A steering committee is set up to monitor project progression or progress. Top management and all users are involved to gain their support and participation. Output: an assignment brief, aka clear definition of output, an assignment brief, also clear definition of problem and objectives. Feasibility study. Preliminary survey to determine whether a project should proceed. Preliminary survey to determine whether a project should proceed. The feasibility study should be conducted quickly and in broad terms, but must be sufficient detailed for management to draw proper conclusions. Feasibility study must include consideration of technical aspect, economical aspect, including cost-benefit analysis, operational, including legal aspect, social aspect. Hence, the main aim at this stage is to rule out bad ideas. Example, proposed project technically possible but too expensive to implement. Feasibility report. The resultant feasibility report should include recommendations, options considered, economic justification for the choice, aka cost-benefit analysis, resource implementations on staff, premises, etc., development plans, and timetable for introduction. If, on the basis of feasibility report, the project is acceptable to the steering committee, a written go-ahead is given to proceed to next stage. System study and analysis, part 1. This stage covers a review of the existing system leading to a design specification for a new system, and so can help develop ideas for a new system. It is a detailed study of current practices, files, documents, working methods, etc. Tasks falling within this stage include: Number 1. Define and identify the objectives of the current system. 2. Establish sources and types of information. 3. Decide on method and collection of data. You can use interviews, questionnaires, observations, documentation studies, etc. Record. Number 4. Record, store, and retrieve information, which will result in the collection of current system data. System study and analysis, part 2. Number 5. Process, adapt, and present information, which will result in documenting the existing system, if there is any. Involves the use of charts and other techniques to help understanding and presentation. Analyze information. Who, what, why, when, where, how are all used. Are current system objectives valid, and are they being met? Identification of key activities and interrelationships within the current system. Identification of strengths and weaknesses of the current system. Opportunities and constraints of the current system. Establishing the resource use of the current system. Statement of requirements. This is the output report from the current stage of the system life cycle. Ideally, it should be prepared jointly by the user and the analyst for management approval. The SOR system, so statement of requirements, should include a criticism of the existing system, the findings of the analysis stage and how the system can be improved, the objectives of the proposed system, a design specification including main interface with other systems, constraints and sample outputs, user responsibilities, and an update of course and development plan and timetables for introduction. System design. This stage is essentially a process of moving from a general outline to a detailed final product. System design leads to a system specification that should provide a basis of agreement and a source of reference between management, users, and analysts. It will serve as a specification of software, programs, dialogues, and manual procedures within the system. The system specification should be presented to the steering committee for approval. Structure of system specification. Should include most structure of system specifications. It is the most time consuming stage of the system development lifecycle. Program development stage involves programming techniques. Modules coded are tested during coding according to test plan designed earlier, meaning during the design stage. This stage is complete when all code is written, documented, and successfully compiled. Coding. It is the most time-consuming stage and therefore requires a lot of effort and so it is expensive. Choice of programming language is important. It aids to save time and money. Use of higher level languages, visual languages, facilitative IDEs, which mean integrated development environments. Codes can be reused, existing libraries, subroutines, or classes, existing modules can be reused. Other R&D, which means rapid application development tools, such as screen painting software, report generators, or application generators, can save time and money. When a program needs to be written for a particular application, selection of the language may be based on which languages have special features most appropriate to the application area, whether the choice of a particular language would substantially reduce development time, whether the programmers have the time and or expertise to master a new language, whether a suitable compiler exists for the hardware the system being developed is intended to use. Program errors. Program errors. A program may have any or all of 4 types of errors. Syntax errors. A statement in the program violates a rule of the language. Semantic errors. Violating rules of language. Semantic errors are concerned with the meaning of language statements. Semantic. Logical errors. The program runs to completion but gives wrong results or performs wrongly in some way. Runtime errors. The program crashes during execution. The translator detects syntax and semantic errors, but the translator does not detect logical and runtime errors. These require rigorous testing for detection and correction, possibly with the aid of a debugger. Program testing. There are 2 ways of approaching testing. Functional testing, also known as black box testing, it is based on a typical extreme and invalid data values that are representative of those covered by the specifications. Logical testing, also known as white box testing, it is based on examining the internal structure of the program and selecting data which gives rise to the alternative cases of control flow. Remarks. Functional testing is not adequate by itself. Logical testing by the programmer during the program development is more efficient. It's more effective. Logical testing by the programmer during the program development is more effective. Test data and test cases. Test data must include valid values, invalid values, and limit values. Select test cases such that every statement in the program is executed at least once. The effectiveness of all sections of code that detects invalid inputs is tested. The accuracy of all processing is verified. The program operates according to its original design specifications. The testing process. Except for small programs, systems should not be tested as a single unit. Large systems are built out of subsystems, which are built out of modules, which are composed of object classes or procedures and functions, depending on the design and language. Paradigm adopted. The testing process should therefore proceed in stages where testing is carried out incrementally in conjunction with system implementation. In general, the sequence of activities is component testing, integration testing, and user testing. Testing stages. Unit testing, then goes to module testing, then goes to subsystem testing, system testing, and acceptance testing. So unit testing and module testing, and also part of subsystem is the component testing. Integration testing includes subsystem testing, system testing. The acceptance testing is included in the user testing. As defects are discovered at any one stage, they require program modifications to correct them, and this may require other stages in the testing process to be repeated. Repression testing. Unit and module testing. Unit testing. Individual components are tested to ensure that they operate correctly. Each component is tested independently without other system components. Module testing. A module is a collection of dependent components such as an object class, an abstract data type, or some looser collection of procedures and functions. A module encapsulates related components and so can be tested. That's looser. An abstract data type or some looser collection of procedure. Loser really. And let me read this again. An abstract data type or some looser collection of procedures and functions. A module encapsulates related components and so can be tested without the other system modules. System testing. Subsystem testing. This phase involves testing collections of modules which have been integrated into subsystems. Subsystems may be independently designed and implemented. The most common problems which arise in large software systems are subsystems interface mismatches. The subsystem test process should therefore concentrate on the detection of interface error by rigorously exercising these interfaces. This is system testing. System testing, and what I was reading was about subsystem testing. System testing. The subsystems are integrated to make up the entire system. The testing process is concerned with finding errors which result from unanticipated interactions between subsystem and system components. It also concerned with validating that the system meets its requirements. Acceptance testing. Acceptance testing, the final stage in the testing process before the system is accepted for operational use. The system is tested with data supplied by the system client rather than simulated test data. Acceptance testing may reveal errors and omissions in the system requirement. Definition: because the real data may exercise inverted commas the system to inverted commas exercise the system in different ways from the test data. Acceptance testing may also reveal that system facilities provided do not meet the exact user's needs or the system performance is unacceptable. Acceptance of testing is something called alpha testing. Bespoke systems are developed for a single client. The alpha testing process continues until the system developer and the client agrees that the delivered system is an acceptable implementation of the system requirements. When a system is to be marked as software product, a testing process called beta testing is often used. Beta testing involves delivering a system to a number of potential customers who agree to use that system. They report problems to the system developers. This exposes the product to real use and detects errors that may not have been anticipated by the developers. After this feedback, the system is modified and either released for further beta testing or for general sale. Test planning. Careful test planning is needed to get the most out of testing and to control testing costs. Test planning is concerned with setting out standards for the testing process. The major components of a test plan are as follows: the testing process, a description of the major phases of testing process. Maybe as also known as maybe as described earlier. Testing process, the description of the major phases of testing process. As maybe as could be described earlier. Requirements traceability. Users are most interested in the system meeting its requirements, and testing should be planned so that all requirements are individually tested. Test items. The products of software process which are to be tested should be specified. Testing schedule. An overall testing schedule and resource allocation for the schedule. This obviously is linked to the more general project development schedule. Test recording procedures. It is not enough simply to run tests. The result of the test must be systematic systematically recorded. It must be possible to audit the testing process to check that it has been carried out correctly. Hardware and software requirements. This section should set out software tools required and estimated hardware utilization. Constraints. Constraints affecting the testing process, such as staff shortages, should be anticipated in this section. Testing strategies. A testing strategy outlines the general approach to the testing process. Different testing strategies may be developed, may be adopted, depending on the type of system to be tested and the development process used. Some types of testing strategies are top-down testing, where testing starts with the most abstract component and works downwards. Bottom-up testing, where testing starts with the fundamental component and works upwards. Threads testing, which is used for systems, usually in real time. Multiple processes, where the processing of a transaction threads is way through these processes. Stress testing, which relies on stressing the system by going beyond the specified limit, and hence testing how well the system can cope with overloaded situations. Back-to-back testing, which is used when versions of a system are available. The systems are tested together and their outputs compared. Implementation. Crossover techniques. Straight or direct changeover. There's the old system and the new system will start exactly when the old system ends. A complete replacement at one go, usually taking place during a select period. It is cheaper, simpler, clear-cut method, but risky because there's no fallback position in case shit goes south. Used when users have previous experience of computerization. The new system is not directly comparable with the old. The time scale is tight. Resources are limited. Example, no extra stuff. The system is small. Implementation state. Project management. The planning and scheduling of resources, staff and equipment. Staff training and dedication. Without interrupting flow of work, good courses and manuals. File conversion, reformatting files for the new system. Documentation check. Ensuring comprehensive and up-to-date system. Deciding on method of changeover, switching over from old system to new system. Handover. Parallel changeover, where there's the old system and at the end of the old system there is the new system. So at a period of time there would be the old system running with the new system. Includes a period where the old and the new system run in parallel unit with each other. Everyone is satisfied that the new system is running successfully and then the old system is dropped. It is an expensive changeover, it involves more work, difficult to make comparison between the results obtained by both systems. It is less risky. Standby facilities, useful cross-check, gradual changeover. It is less risky. It's used by standby facilities, useful cross-check, gradual changeover. Phased or incremental changeover. The changeover is in a number of stages rather than all at once. Division may be based on location, say on branch of retail group each month. Subsystems, say sales, order processing system, then payroll system, then accounting system. Say in a customer account file, names beginning A to F, then G to L. Spreads the burden of the workload over time, presents an opportunity to learn from problems of a previous phase, takes longer than other changeover methods, difficult to control, system working in two modes. Sometimes a part of the system which can be treated as an entity is upgraded. Example, the stock control system of a single shop which forms part of a whole retail chain. Changeover of the entity is done using direct or parallel changeover. When the pilot implementation is satisfactory, the project to upgrade the whole system is undertaken. Therefore, this is a part of the system, not the entire system. I think this is the pilot changeover. I'm not sure though. Let me check. Pilot. Yeah, this is the pilot changeover. Changeover. Yeah, so this is the pilot changeover. Control and review stage. Control, setting and redefining standards against which performance can be compared. Measuring planned against actual performance, taking corrective action where necessary so that the system meets its objectives. Review. At predefined intervals of time, systems should be reviewed to give overall picture of progress made. Findings help any subsequent